Hi, welcome. Today we're going to explain to you how to solve an exponential problem. There are 4 ways to solve an exponential problem: converting to log, common base, taking the log of both sides, or factoring with u substitution. Let's start with a simple one, using common base. Let's start with 3x to the third equals 9 to the x. Now, we have a 3 here and a 9 here. 9 is also equal to 3 squared. So we can change the base here to be, so we have 3x on this side, and 3 squared, which is 9, all to the x. Now, if we expand this part, we have 3x third equals 2x. Now, since we have the same base here, we can set their arguments equal to each other. So now, we have x cubed equals 2x. Now, from x cubed equals to 2x, we want to make sure that we can set this equal to 0. So we will bring this over by subtracting it. We have x cubed equals, x cubed minus 2x equals 0. Now, there's an x here and an x here, so we can factor out an x. We have x squared minus 2 equals 0. Now, we're going to set each part of the equation equals 0. We have x equals 0, and x equals the square root minus 2. Alright, let's try another one. How about 4x squared plus 3x equals 16 fifth power. Now, we know that 4 and 16 can have the same base. So we can change this to 4 squared. So now we have 4x squared plus 3x equals 4 squared all to the 5th. Now, we have the same base, which means we can also set the arguments equal to each other. So now, we have x squared plus 3x equals, after we expand this, 10. Now, the easiest way to get rid of this is by moving this over and solving it like a quadratic equation. So we have x squared plus 3x minus 10 equals 0. Now luckily, this problem is easily factorable, so we don't need to use the quadratic formula. X, 3x, so we have to use x plus 5, x minus 2, 0. Now, we set each part equal to 0. X plus 5 equals 0, x minus 2 equals 0. We're left with x equals -5, x equals 2.
And so our next method for solving exponential equations is taking the log of both sides. So let's do a practice problem. So 3 to the 1 minus 2x equals 4 to the x. So taking the log of both sides, you pretty much either stick log base 10 or ln, which is natural log, in front of both sides. So log base 10 of 3 to the 1 minus 2x equals log base 10 4 to the x. So next we want to take these exponentials, these exponents, and using one of the properties, move it to the front. So 1 minus 2x in parentheses, because it's one factor, and then log 3 equals 4 to the x. Nope. So the next step will be distributing the log 3 to both of these terms. So log 3 times 1 is just log 3 and minus log 3 times 2x, you just put the 2x in front, log 3. And then equals is still going to be x log 4. So the next step will be getting the x's, both the x's on one side. So we'll add the 2x log 3 over to this side. So after we add the 2x log 3 over to the other side, we'll be left with log 3 equals x log 4 plus 2x log 3. So now that we have the x's isolated on one side, we want to factor them out. So log 3 will stay on this side, equals, and then we're going to factor an x out of both terms. So x times log 4, and the 2's left, so 2 log 3. So now that we have the x multiplied by this whole term, to isolate x, we can just divide by this whole term to the other side. So coming up here, x will equal log 3 divided by this whole term. So log 4 plus 2 log 3. And so we can simplify this by moving the 2 up to the exponent on the 3 using one of the properties. So x equals log 3 all over log 4 plus 3 squared, which is 9. And then using the addition property, we can multiply the arguments together, leaving our final simplified answer as log 3 over log 36. So if you were to plug this exact answer into the calculator, your approximate answer would be x equals 0.307.
Yeah. Okay, so we're doing converting the logs, and our question is going to be 5 to the 2x equals 100. So what you do is you write log, and then you take the base, which is 5, and then put it whatever's on the other side right here, which is 100, and then you take the 2x down to the other side of the equation, and then you divide. You want to isolate x, so you divide 2 on both sides, and then x equals log 5 100 divided by 2. And to get the answer, all you have to do is plug it into your calculator. If you plug it into the calculator, the approximate answer is 1.43.
We're going to do our last method of solving exponential equations, which is by factoring. So, the problem is going to be 2 to the 2x plus 2 to the x plus 2 minus 12 equals 0. Now it looks pretty complicated at first, but we're going to use u substitution to make this problem a lot easier. So we're going to say that u equals 2 to the x. So now we're going to substitute u in for all instances of 2 to the x in the problem. So for 2 to the 2x, well, if you separate that out, it's really 2 to the x times 2 to the x. So that is u times u, which is u squared. So that becomes u squared. Now we have 2 to the x plus 2. So that separated out is going to really be 2 to the x times 2 squared, right? But if 2 to the x equals 2, and you're multiplying it by 2 squared, which really equals 4, you're actually going to have 4u. So that becomes 4u. The 12 stays the same, and it all equals 0. Well, now we can factor this pretty easily. So you're going to do u plus 6 and u minus 2 equals 0. And now you're going to set each factor equal to 0. So u plus 6 equals 0, u minus 2 equals 0, u equals negative 6, and u equals 2. But now we have to plug 2 to the x back in for u. So 2 to the x equals negative 6, and 2 to the x equals 2. But we know that 2 to any power can never equal a negative number because the graph of an exponential has an asymptote at y equals 0. So that's out. So now we just have to solve 2 to the x equals 2. Well, since they both have the same base, we can call 2 to the x and we say 2 to the first. Therefore, x equals 1. So, in conclusion, we have showed you 4 different ways to solve logs. First, you can convert to common bases. Second, you can take the log of both sides. Third, you can convert the whole problem into a log equation. And lastly, you can factor using U substitution. One very important thing to remember when solving exponential equations is that any answer you get will always work in the problem. You don't have to test it because exponential equations have a domain of all real numbers with an asymptote, however, at y equals 0. Therefore, anything you plug in will always return a value.